So I take my part 2, 1, 2, 3 from basic introduction.
Oh my god.
Quite a bit.
I'm sorry. Guys, look at this brown color. It's starting to fade on the tissue. But this where? This is due to the attachment of the tissue. But how do we determine the color from this tissue? You can try the experiment called chromatography. But what is chromatography? Let me explain.
Chromatography in real life, CHM256. So this is our group mate.
These are the learning point of this slide. Define chromatography, type of chromatography technique, and application chromatography in real life. What is chromatography? Chromatography is a technique used to separate mixture of soluble substance. Color substance such as food coloring, ink, dyes, and plant pigment can be separated by chromatography. History of chromatography. Michael Speck invented chromatography in 1906. During his research on plant pigment, he used liquid absorption column chromatography with calcium carbonate as absorbent and petrol ether, ethanol, mixture as inulent to separate chlorophyll and carotenoid. Principle of chromatography. Components of a mixture are separated based on their interaction with stationary phase and mobile phase. Component with stronger attraction to the stationary phase move slower. Separation result in decreased band for analysis. These are the example experiment. Step 1. Add 5 mm of solvent into a beaker. Draw a line in pencil on the chromatography paper about 1 cm up from the bottom. At the spot of the ink, you are testing into the line. Question for step 1. First, give an example of a solvent. Second, why does the line need to be drawn in pencil, not a pen? Third, why do the spot need to be spaced out and not directly next to each other? The answer is, first, water or ethanol. Second, pen contains soluble ink which could appear on the chromatogram and contaminate the ink spot. Third, spot could merge together and make the result hard to read. Step 2. Carefully lower the paper into the solvent. The solvent must not cover the pencil line or touch the ink spot. Observe as the solvent moves up the paper, separating out the color mixture with it. Question for step 2. Why is it important to make sure that the solvent is not covering the pencil line or touching the ink spot? The answer is, the solvent could wash away the ink either fully or partially. This will affect the result. Step 3. Leave the paper in the solvent until it is close to the top of the paper. Take the paper out and immediately draw a line in a pencil using a ruler to indicate how far the solvent traveled up the paper. This is known as the solvent front. Question for step 3. Why is it important to immediately draw the solvent front line after taking the paper out of the solvent? The answer is, the solvent may evaporate quickly, so it will be hard to see how far the solvent traveled up the paper. How does chromatography work? We're separating out different pigment in ink and dyes. Some of the pigment are more soluble in the solvent than others. Pigment which are more soluble will move further up the paper. Analyzing chromatography. RF values are used to identify unknown chemical by comparing them to a range of reference substance. The RF value for a particular substance will always be the same if the same solvent and stationary phase are used. The RF value of the red spot is 3/5, which is 0.6. These are the formula for RF. Distance traveled by the spot over distance traveled by the solvent. Analyzing chromatogram. We can also view which chemical are present in dyes and ink, such as chemical 2 and 3 are present in the ink sample, but 1 and 4 are not.
Key terms in chromatography. First, elution. Solids are washed through the stationary phase by the mobile phase. Second, eluents. Solvent used to carry components through the stationary phase. And third, retention factor. Measure of the distance traveled by the solvent front. Types of chromatography. Planar chromatography. Paper chromatography, PC, use cellulose fiber as stationary phase. Thin layer chromatography, TLC, use liquid as the mobile phase such as silica or aluminum. Column chromatography. Gas chromatography, GC, use mobile phase is gas. High performance liquid chromatography, HPLC, a precise high pressure method of liquid chromatography, mobile phase is liquid. Thin layer chromatography. Component move across a cold plate. Stationary phase, thin layer of silica or alumina on a glass plate. Mobile phase, organic-inorganic solvent. First, preparing and activating the TLC plates. Second, spotting the TLC plates with sample. Third, developing the TLC plates. Fourth, drying the plates and then visualizing the substance spots. And lastly, measuring the RF value. Application: purity testing of products, identification of organic compounds. Paper chromatography. stationary phase, water molecules trapped in cellulose fiber of paper. Mobile phase, organic solvent, example ethanol. Mechanism, partition chromatography, liquid minus liquid. Application, separation of plant pigments, analysis of ink and dyes.
Over to the application of chromatography. Firstly, in the pharmaceutical application where we can use it for analysis of antibiotics and steroids, or any use of drugs, formulation and ensuring purity and potency of medicine, detecting drug metabolites in biological samples like blood or urine during clinical trials. Example, identifying impurities in antibiotics using HPLC. DNA sequencing in genetic studies often relies on chromatography techniques. Moving forward to food industry, where it acts as a detection of additive and antioxidants, ensuring food safety by detecting harmful additives such as artificial preservative, colors, or sweeteners. Quality control progresses to monitor nutritional content. Example, HPLC is used to measure sugar content in the beverages. Gas chromatography can identify volatile compounds contributing to the flavor and aroma. Moving forward to forensics, where it can analyze all drugs and poisons. Analyzing substance in crime scenes, examples such as drugs, toxin, or explosive. DNA fingerprinting using chromatography to separate DNA fragments. Example, detecting alcohol levels in blood samples through gas chromatography. Thin layer chromatography is often used for quick screening or illicit substance. Moving forward to environmental monitoring, where detection pollutants in water and air. Monitoring water pollution by detecting contaminants such as pesticide, heavy metals, or organic compounds, where air quality analysis identifying volatile organic compounds, VOCs. Soil testing to detect harmful residues, examples such as gas chromatography, measure levels of industry solvents in the atmosphere. Moving forward to application of chromatography in hospital, where it can detect blood or alcohol level in the patient's bloodstream.
The application of chromatography in the hospital section, where it detects blood or alcohol levels in patient bloodstream. The blood alcohol level measurement using GH gas chromatography to detect the concentration of blood alcohol in the bloodstream. Example, diagnostic of alcohol poisoning cases or assessment of DUI cases. Drug and toxin detections, such as liquid chromatography, mass spectrometry, LCMS, is used to detect drugs, metabolites, or toxin in blood. Example, in drug overdose cases and therapeutic treatment supervision. Also, it detects the biomarkers and metabolites. HPLC is used to measure biomarkers such as glucose, hormones, or lipids. Example, diagnostic of diseases such as diabetes, or hormonal disorders.
Moving forward to advantages and disadvantages. The first advantages of chromatography is cost efficient and versatile, and it's quick and easy to set up and suitable for separating complex mixtures. But the disadvantage is it is limited to small sample size, not ideal for volatile compounds, and requires expertise for quantitative analysis.
Last but not least, conclusions. Chromatography is an essential technique for separating and analyzing mixture. Understanding principle and types enhance its application in the various fields from scientific research to industrial process. Chromatography is indispensable